Hello. So today I'll talk about Adam. Is a real-time movie that we at Unity made. I'll start showing part of it. It will not run in real time right now because it's on Mac, unfortunately. Mac's not good for real time in this case. But you will be able to download the executable and try it yourself. Hopefully there is some sound. So I'll start talking about the movie itself. The movie, the sound is pretty low at first. So the movie it's a real time. It runs pretty much 30 frames per second on an average rig, on an average machine with GTX 980. And it's set in some form of a future, which is kind of post-apocalyptic. And the human bodies are quite expensive there. So if instead of a jail, what they do is they put humans into the robotic body as a some form of a jailing, basically. They put them into robotic bodies and then release them into this wilderness. And meanwhile, their bodies are reused for something else. That is the background of this kind of movie. And our creative director wanted to explore this idea of how the person would feel in the robotic body. So at first, he's figuring that out. He is kind of surprised. Okay, we can continue with the movie later. Meanwhile, I want to talk. Come on. So, well, you probably know Unity mostly from mobile, and it is true. For many years, our main platform probably was mobile, and up to date, it's actually top 1,000 games. 30% of the top 1,000 games on the App Store and Google Store is actually made with Unity. But recently, last 2-3 years, Unity is becoming more and more viable platform for consoles and desktops. So many of the desktop games, actually at some point there was half of the top 10 Metacritic games was made with Unity. Nowadays consoles as well, console games, Recore just released, Firewatch. So all of them are made with Unity. 70% of the VR, that's what people say, is made with Unity. And according to the Palmer, Lucky, he said that 90% of Gear VR is made with Unity. So that's the kind of state of Unity right now. And the short talk outline. First, I want just to cover why we're doing this. Why do we do this real-time movies? Why we do that internally? Second will be, I will talk a little bit about the iterative approach that we use to make those movies. It is not really it's a little bit between how the traditional CG, computer-generated movies are done in film, and it's somewhere between that and how the games are made. And then I'll go through production. I'll show you some interesting images and how the demo was actually done. To answer the question why, I'll show you the visual evolution of Unity. So that is a 2009. It was a pretty successful game back then on mobile, but it's kind of simple, right? So that is 2011, another game made with Unity. It's a shadow gun made by Mad Fingers. Actually, Mad Fingers are presenting today in the entertainment area, if you want. So you can see some progression. That is another demo for mobile made with Unity. You can see, you can see some visual progression from year to year. This is last year, some architectural visualization that we did with Unity. And as you probably know, last year we did a blacksmith demo, as well a real-time movie. And this year it is Adam. So for us, we think it is very important to work on these internal movies in order to get this visual progression. Why? Well, first of all, it's a dog food. Dog fooding? Eating your own food, whatever. So our own team, both Blacksmith and Adam is created by our own internal demo team. It's a pretty small team, but they use Unity. They are set up pretty much as any small self-sufficient team would be set, and they have their own programmer, they have their own art directors. So we watch how they do demos, we see where they struggle, and we try to fix that in the engine. It's a very nice closed feedback loop because they can feedback about all the problems, and it's as well a nice ground for the collaboration between the research team. For instance, we have a new graphics research team in Paris, and it's a very nice collaboration between the research, developers, and artists while they're working on such movies. Pretty much the physically based shading, image-based lighting, many things that you see in Unity 5, they were tested in some form of the demo, technical demo before. So, as well, why do we do something what looks like a bit like a traditional CG? Is because the games are coming closer and closer in terms of the visual quality to traditional CG. And we want to learn from that. And in order to learn, we need to basically do something like that ourselves. We learn practices, how to do a very big content, how to do an interesting content, and as well we understand where we can blend between the traditional movie development and games, what we can bring from games into development of those movies, some techniques basically. Another thing why it is important as well, we think that VR, and VR is kind of becoming bigger and bigger. For VR, visual quality is extremely important because it can destroy immersion without visual quality. It can destroy immersion. So that's why we think that quality of the graphics is very important for Unity as well. So some things that were developed in parallel or were tested while the team was working on the demo. It's improved shading. The interesting thing about the improved shading is that we made sure that number of tools that the artists are using nowadays, like a Substance Painter, Marmoset tool bag, and Quixel Dido, that they almost 100% look the same, the content. So artists don't need to imagine how it will look in the engine. It's actually, in their tools, it already looks exactly the same as the content when they put it in Unity. That speeds up the iteration time a lot. Well, basically, this demo required certain visual quality, and for that, we were developing in parallel image effects, post-processing, or what we call image effects, or post-processing stack, which is available on Bitbucket as an open source right now. But it was developed and tested in the movie itself. Another interesting thing as well, this is research that was done by our Paris, as I mentioned earlier, special graphics team that works on research. They worked on the real-time area lights, and they was very important for the demo itself. And the demo as a content served significant purpose. That paper was presented at SIGGRAPH earlier this year. Volumetric lighting is something as well tested quite heavily in this. We developed Alembic Importer, or rather our team in Japan developed Alembic Importer, and we used that in the demo. This part, for instance, it is not real time actually, where he is turning his arm, wrapping on the arm. It is simulated in 3D Max and then exported as an Alembic file, that particular part on his arm. It was just why we did that. For instance, we want our engine to be very flexible, and we want to make sure that someone can write plugins like that, plugins that allow to plug Alembic, for instance, to plug into common CG workflow. That is mostly geared not towards the game development, of course. That is mostly geared towards CG companies that are starting to use real-time tools as well. This is another interesting tool that we used for the demo. It is a high-fidelity simulation, which runs inside Unity, all those cables, for instance. The guy itself, he is, of course, animated by the animator, but those cables, they are procedurally simulated. This simulation is way too expensive for the run in real time, so it is actually, but it runs in Unity, but we bake it into some form of animation for those cables. People do that in games quite often as well, for the cutscenes or for the destruction, that you can destroy something or you can simulate and then bake it and use it in the cutscene, or use it as on an event as a trigger. So one interesting thing is this hybrid approach that we use for making the movie. So why it is hybrid? It is because we mix between what commonly in the CG, for instance, industry, what you see is kind of waterfall type of process, where people first come up with the storyboard, then it is being locked, then people go into the pre-production, the results are being locked, and it's lockstep process where every part is being locked, everyone agrees the quality is good, and then they proceed on to another. At the end, they have movie. In the games, we usually work differently. We work more in an iterative process. So we wanted to mix that together. And real-time tools allow that. The team is very small. It's only 8 people. But as I said, it's a self-sufficient team. Of course, they would use contractors when it is necessary. So again, about our hybrid approach, we have a much longer pre-production than usually is in the movie industry. And it's a very blurry line, essentially. And I will talk in detail a little bit later. You can see here, it's very early stage of the demo. It's already in the editor, so a lot of time the pre-production and prototyping was happening directly in the editor in Unity. It starts with the very simple blockout, and then artists iterate on the quality, add new meshes, add new animations. Once they are happy with the quality, they continue. The difference, as I said, there is no locks basically. It's always working. They are always working and improving on the content, which is constantly running in real time. They constantly see it in the editor. They know how it looks. It allows a director to experiment a lot. We as well mix a lot of game technology, like state machines on the right side for the crowd simulation. I will show a little bit more for visual effects, and for the post-processing we use technology which is very common for the games. It's actually game technology, which allows us to do real-time, to achieve real-time performance. And here you see from you on the right side, it's our director talking with the actor, and basically this is the very common CG workflow where they would capture the actor performance with the high quality motion capture. But for the additional characters, we would use something more gamey and more real-time, and something that you can experiment much more, like the state machine and animation blend trees. So, storyboard, that is the very start of the demo. However, it is very rough. It was art director working with our concept artist, and they were fleshing out the idea, but they don't go really into the details with the storyboard. I can show you how the storyboard looks like when it's put on top of basically this short animatic. It is just the same storyboard images put into one hour to see how approximately idea will look like. But instead of spending more time and making a better storyboard, the next step what team did, we went into the editor and start putting things in Unity directly. And you can see here it's the first previews. The lighting is wrong, of course, but there are some form of animations. This is not a mock-up animations. It's just animators animating it by hand really quickly, just to get the feeling how the demo will look like. And you can see that the director already trying the shots that he wants to see in a demo with the camera. It's just a fly-through camera in the editor. The next step is adding a little bit of the lighting and a little bit better camera. As well, it's a early steps, trying to understand how the demo will look like. Is the emotions for the director, that is a very important step. He's trying to understand if he communicates his idea right. So for me, for instance, I think like real-time editors like Unity is very opening possibilities for the directors to work with the content like that. It's a very fast, they iterated like hell inside the editor with a couple of artists. So what we did next is we set up a very cheap mock-up directly in the studio. It's based on this neuron thing. It's pretty cheap tech. I can show you the video, how it looks actually. So you can see that on the right side there is a actor with the setup on him. It's not a camera based, it's just a sensors directly on his body. You can see those bands, straps attached to him. So that is like experimenting with some form of a motion capture in-house to see, to quickly put it into the editor, to quickly put it in together with other content in order to get the rough idea how it will look like. Of course, by the end, this motion capture, the quality of this solution is way too low. You cannot really use it for anything for the production, though we actually used a couple of shots made like that. But it is just the first pass to quickly understand where the movie is going. And afterwards, later, there will be a proper pass with the motion capture with the Vicon cameras you will see which is much more expensive as well. You cannot spend that much time on it. So trying it first with a very cheap solution was cutting costs as well. Okay, now the mock-up is put in the engine as well. So I'm just showing the progression, kind of how it goes from very ugly looking to mediocre looking, but with better animations. Again, next step as well. It's just the post-processing, added on top a little bit better lighting. So the team can, like the different sub-teams can work at the same time. The animators can work and modelers can work. There is no locks. Once a new iteration of the content comes in, they would put it in the engine. As I said, afterwards was the pass with the mock-up, like a proper Vicon camera-based solution. And you can see the director, our director is explaining to the actor how he wants him to move. Our director is Bulgarian, and the studio is in Bulgaria in this case, the mock-up studio. So that's why they're talking in Bulgarian language. He's a professional actor in a stunt. So some more shots from the Vicon session. So we did a 2-pass of Vicon session, actually, again, because of it's pretty expensive thing, so we had to time it well. So director came in already with the ideas because of the cheap mock-up solution before. He came already with the ideas, what he wants from the actor performance. He tried it himself as well before acting a little bit with the chip setup with the neurons. As well, a lot of content was already put in the engine, in the editor, so the director could see what he wants from which camera sides and stuff like that. So it was much easier to do a mock-up with that knowledge. However, we needed 2 passes to get the final quality. There is a mock-up of the camera. You can see how the camera was captured. In the end, it actually proved to be too hard to capture the camera completely with the mock-up. So what we did instead is creating a library of different camera animations, and then animator would go in the end and stitch them together instead of filming them completely in one go or filming them together with the action. It proved to be too complicated. So instead, it was a library of animations which are very lifelike, but not exactly the way the director wanted them. So in the end, they were stitched from multiple different shots. I'll go a little bit about the design of Adam itself as a character. So Adam is a convict, jailed in his body, and this is the early mood boards exploring of the idea. Director wanted him to be very vulnerable, exposed, and scared. That is the early concept art. As well, you can see that concept artist is exploring the ideas. However, I can comment on this particular image is that what director didn't like about this experiments, or he picked something that would look more human-like, because you can see that some images are a little bit too robotic, a little bit too alien in terms of look. However, director wanted the main character to be very human, although he's a robot, but something that people could relate to easily. So he picked forms which looked like human, closer, like 2 eyes, not 1 eye, for instance. More exploration. Here, it was actually quite complicated to make a body of the Adam, because we wanted him to be able to move as freely, to move like a human. We didn't want the body, the mesh and the physical kind of setup of the character to limit the performance of the actor itself. At the same time, 3D modeler and director and art director, they didn't want to cheat too much. They didn't want metal to be bending, basically. They didn't want to be gummy, metal look like some form of plastic or gum. So it is pretty much an engineering problem that they were trying to solve. I mean, they probably took it a little bit too far. It was probably too interesting for them to do that. But you can see as well the upside of that it became very modular. So it was easy to construct different robots. So later on, it proved to be a good resource saver. Some more exploration. The face, of course, was very important for the Adam, and you can see a bit more exploration of how the face could look like, as well a little bit more alien, a little bit more human looks for the robot. And here it's masks for Adam. And I want to talk a little bit. It's interesting here because at first, you can see in the top corner there, at first the face of Adam was a bit more human-like, but it proved to be very uncanny. Uncanny Valley kind of type of uncanny. So you can see a progression where the modeler and the director is trying to strike some sort of a balance where the character is interesting and can relate, can communicate emotions, but is not scary and not repulsive. So the final idea after multiple iterations is both iterations in terms of the sketching and iterations in terms of modeling. So what they came up in the end is the eyes is the only thing which is left from kind of human, and the rest of the mask is molded and devoid of features. So mask as well, what they wanted to show is that the mask is, according to the story, mask is 3D printed. It's very cheap. That is why Adam actually manages to break it in the opening shot, in one of the opening shots. Idea is to show that they are very fragile and no one really cares about them. It's just like a displaced body, something that you can throw away. But at the same time, it was an interesting solution, the breaking of the mask, to make Adam stand out from the crowd. So when he breaks the mask, later on in the movie, it's very easy to see him from the rest of the robots. Just for the example, it was one of the like early sculpts of the Adam. You can see actually as well that it is interesting that you see the bones on the back of the Adam. This is something that the director wanted because it reminded him of how the patients look in hospitals. They usually have this thing that they put in front, and there's a hole in the back, and it shows how vulnerable this body is. Director wanted some form of clothes, but it's kind of stupid for robots to have clothes. Why he wanted clothes? Because it makes it more interesting and it's easier to distinguish between different robots as well. So he wanted something to put on them, but putting clothes is kind of stupid. And he wanted this orange thing because it looks like a convict, they are convicts. And you can see here that it's quite easy to, just by changing the clothing, it's very easy to get a different looks. So the final idea was that it is some form of a wrapping, that these robots are coming into, like when they are produced, they are wrapped into something and they just sent out, and some of them just tear parts of it, and that's why it's not really a cloth, it's just some form of a packaging. Oops, sorry. Yeah, so that's the final sketch. It is was working in parallel, so it's not a sketch that someone came up, the concept artist came up by himself. It is a concept which is kind of overpaint over the mesh of the modeling. So it's like it was step-by-step process. The modeler would improve and try something new with the mesh, and then the concept art would go and overpaint it, add a little bit more details and go back like that in this cycle. You can see a bit more detailed body of Adam. And as you can see the difference, the standard convict and Adam, they look a little bit different. It's an evolution from the previous, how simple was the skeleton and setup at the start of the previous, and it's like in a matter of 2 or 3 months. It's more complicated. That is a final render, basically the quality control render for Adam. You can see the immense amount of details in the body, in the robotic body. It is, as I said, pretty much engineering-wise a sound setup for a robot. how, yeah. It's as well interesting maybe for some people that the modern GPU can easily render not even tens, closer to 100 of robots at this complexity. So you can see the models, you can see the layers inside of the robot. Here it is a mask which was broken in 3D Max with the bullet physics plugin, and then it was modeled on top a little bit. So you can see the original mask and broken mask. This is a convict body. So it's a standard starting place for a robot. It has a full wrapping, and we wrote a shader which allows to blend between fully wrapped and unwrapped, and that is how different robots come to be. This is the final as well textured version, and the texturing was done in the Substance Painter too. I'll just show the mask is a little bit translucent, so everything that is behind the mask is rendered into the texture and blurred a bit, and then used as in the final shading. It's kind of common nowadays to put the camera in front of the actor, film the eyes. We couldn't find any other way to transfer the eyes into the motion of the eyes, so it was actually modeler would animate them. However, he was looking at the reference of the real actor, and it is quite interesting as well because the eyes were important part of the performance. The team experimented quite a lot to get this look of the eyes. It's actually something resembling camera in terms of shutter and how to say blades. Something that as well looks mechanic but looks resembles a real life as well. So most of the performance, like acting performance, is done through eyes of the character. This is the final shot. So for the crowd, as I said, you can see the blends between the two different, it's just blended, it's like two textures overlaid on top of, not only two textures, but two sets of the textures overlaid and unmasked in different places. So we can get a different looking robots. This is a pretty simple skeleton for the robot in the background. It's a state machine for him. So this comes to be a very kind of gamey-like technology, using the blend trees and state machines to run all those robots in the background. And we wrote a special plugins for the Unity to be able to navigate those to navigate that flow of robots. It actually was done by a guy in Lithuania.
Can I give you one question?
Yes.
How did you do the face tracking? Did you use face tracking technology, such as putting points all over their face and just animate?
No. No, because it's a robot, the face is not really moving, so we didn't use any tech for the face itself. It's pretty much static. The only thing which moves is eyes, essentially, and for that, it was actually animator looking at the video reference of how the human eyes are moving in that case.
So are you looking for the fastest way to animate things like moving, like running, how the character moves and so on, or you do this in your computer and that's it?
Not sure I understood. Oh, it's a motion. So there's two things, right? There's a motion capture for the for the main characters.
Motion capturing, yeah.
Yes, it's a motion capture for the main character. It is a motion capture for the rest of the robots as well, but it is cut and put into blend trees as you would do in a game, kind of. It allows to mix between the different animations when they walk outside. So it's like a small animation, small clips of the animations, which like walking cycle, running cycle, or stumbling, going left and right, and then basically the script drives them the crowd control script drives them through those animations. But the main character here in the middle, like the Adam, he has animation which is specific for him. It's like a one long animation done through the mockup. I can come back to the question later. So I don't have much time, so I will just show the environment a little quickly, the progression. This is as well a sketch for the environment, starting point. This is the early version in Maya or 3D Max, I don't remember. This is in the engine. The interesting thing is as well, there was a cycle. The concept artist would take a screenshot from the editor, from the game engine, and overpaint on it. For instance, here you can see this kind of geometry put into the engine, and then the small detail is actually painted by the concept artist, and then next step, it's hard to see, it's dark here, but it's in the engine again with those details added. So it's like the modder and concept artist would be working in cycle, overpainting on the models, showing the model where to put more details, and on like that. So it's a kind of destroyed world. It's a concept art and references for the destroyed world that the demo is happening in. As well, you can see the progression from the concept picture to the first block out, and then a little bit more complicated block out. The interesting thing as well is like why to do the block out in Unity is because you can mix with the animations very easily. In this case, those characters, they are already animated, so they can give, and the lighting is already as it will be in the engine, so it is easy to see the results quite quickly. It's an interesting as well part. This tower happened very late. Is when the director was looking to make the scene a little bit more interesting. So he had to cast some form of a shadow on the characters at some particular shots. So he put just a box basically, and then he got the interesting shadow, interesting light look, and then the modeler would go and add something, like quickly make it from the parts, just put it instead of this box to actually cast a real shadow. So I'm just talking about the kind of process. This is as well the early shots of the exterior. If you would notice, they look like ice, like a winter, but because it proved to be too complicated and too time-consuming, and it was as well because of the iterative process. It was easy to switch to a bit different look. That was easier to achieve, like an early spring look, and you can see the characters coming. I will skip those. I really like these characters, Sebastian and Lou, that come in the end, but I will skip them, I guess, this time. I'll just show you a bit of it's again, the concepts. The interesting thing is that there's certain connection between the old robots that start at the beginning of the movie and this one's, because they use the same components. The heads are different, but some components are actually the same. And plus, this it's she robot, and she's using tank. She found, because they live in some sort of a junkyard, basically, she found some parts of the tank, the tracks, and put on her as a armor. I'll just show you the simulation of the body. So this is on that side, there is a body which comes from the motion capture, simplified body from the motion capture, which will drive the simulation. And on that side, you can see the physical bodies which are simulated, which are driven by that body. And you can see them running in the engine. So this skirt is some form, it's not really a cloth, it's some form of a gummy thing. It's what the director wanted to look like that. And it's a cape. The cape was super complicated, actually, because of so many layers of objects. So this, in the end, this animation would not run in real time. The simulation would not run in real time. We just would bake it into an animation. But it was really easy to simulate it directly in Unity. All those physical objects are actually physical objects in Unity, in the editor, simulated at it would take around 10-20 minutes to simulate because of so many layers. The simulation engine is this Current FX. It is offline. It's essentially the core of it is an offline physics simulator, high quality. And come on. So when he goes out, the interesting thing here, when you start seeing lots of robots. So director wanted to show basically the power, like how many, he was trying how many can we render, and it ended up that the performance was still holding, but he didn't have enough space in this shot to put them, more of them. So So in terms of animation as well, this is motion capture. It's an actor playing with the gun and shooting. It's just a normal motion capture. For instance, those guys as well, it would be, in a distance, that would be just a loop of the animation. As well, as I said, using these game-like technologies, like normal things, like the small clips and blending them together, that allows to easily change the script, to easily experiment. So if the director doesn't like the particular character, he can move him a little bit. We don't need to redo the animation. So something that would happen in a game, kind of. It's just a script, some form of a code which runs this crowd. There are some kind of motion field, vector field, which tells characters where they should going pretty much, but the script reads through this vector field, sees the direction, and then looks for the best animation and that should be running on the robot. For those kind of robots in the background. So if you notice these tablets on the front, they got information about their, how to say? Sorry?
Identity?
Not exactly, both identity and why they're here, what type of crime they, so yeah. He does something that the crimes got erased, kind of. So in those shots, I quickly skimmed through the screen space reflections and the anti-aliasing. You can notice that it's very important in those shots, but because there is a lot of water above, and there is a lot of shiny places on the robots, and there is a lot of aliasing, a lot of specular movement. That is anti-aliasing was very important, and the guys like. Different team, the tech team spent at least 2 months trying to optimize the temporal anti-aliasing for that. For those shots, so they are stable and don't flicker too much. So the good thing is all that tech is kind of part of this technology is available on the Bitbuckets and GitHub nowadays. And we are going to release the same thing as with the Blacksmith. We are going to release the content on the asset store. And that technology goes into powering the games. So I hope in a year or two the games will look like that on the desktop and PC made with Unity. That's it.
Thank you very much.